Hi, okay, welcome to session 10. We're going to be looking at Pythagoras today. Before we do that, we're going to do the recap. So if you're on the printed version, fantastic. I'm going to keep the screen big as normal for those of you wanting to work directly from the screen. I'll scroll through and then we'll take a look at the answers. Okay, so hopefully you've sort of paused at the right places and marked, and you're spotting things like different units that are there to try and trip you up. Okay, right. Pythagoras. So Pythagoras' theorem has the formula a squared plus b squared equals c squared. And some students are not a fan of the formula. It just feels like a lot of work. It feels more complicated than it is. So I'm going to try and do something to help those particular students in particular by just popping a little bit of color into this. And you'll find that it just makes it really, really simple. So if we, first of all, look at that triangle, we can see it's a right-angled triangle because of the square corner. Now, Pythagoras' theorem, a squared plus b squared equals c squared, only works in right-angled triangles. So you can't be applying it to just any triangle. You can insert a line to create a right-angled triangle and then use it, but you can't just willy-nilly use it, okay? Now, the right angle can be incredibly useful. If we put the arrowheads on, a bit like we did when we used them for the base times height, it points to two really critical sides. I'm going to highlight them. It points to these two. So the two sides that make the right angle are the first two letters of the formula, and it doesn't matter which way round these are labeled. That could have been B, that could have been A. It really makes no difference whatsoever. So as long as I know that my right angle is pointing to the first two numbers that I need, and then you leave this one blank, and it's this side of the equal sign. Now I'll show you that in action, but it's really helpful at just making the use of this formula simple, okay? Also, it means it doesn't matter how I give you the triangle. You can't mistake the two sides that you need to identify, okay? You can't go wrong. All right, let's actually put some, I'm going to get rid of the color a moment and put some numbers on. So we are going to look at 3 centimeters on this edge, 4 centimeters on this edge. We're going to label that one X. That's the side that I'm being asked to work out. So this is what I do. I've got my pointing right angle, which is this side and this side. That's 3. That's 4. So I'm going to replace the A with 3, pop a little square on it. I'm going to replace the B with 4 and pop a little square on it. The C is going to be replaced with the X. And now what I've done is I've taken the information from the diagram and I've put it into the formula in the right places. Now I've got maths I can actually do. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. So on this left-hand side, there's a whole load of maths I can actually do. On this side, there isn't anything other than it's equaling x squared. It's equaling x squared. Now, if I want to know what x equals, I need to get it on its own. So at this stage, because I've got this nice and tidy and it's down to one number, I'm going to take this power 2 and I'm going to drop it on the other side of the equal sign so that it's gone and x is on its own. So the opposite, the inverse will happen as it lands. So like when I carry a plus, it lands as a minus. When I carry a times, it lands as a divide. So when I carry a power 2, what does it land as? And hopefully you are shouting at the screen, square root. So I've now got x is equal to the square root of 25, and the square root of 25 is 5. So that's it. That's Pythagoras in a nutshell. It's making sure that you take the information from the diagram, put it in the right position, and then work the maths through. So it really just turns into solving equations very, very quickly. All right. So let's do another one. If you're feeling ready, please feel free to start straight away with the whole having a go. If you're thinking, I wouldn't mind just seeing that one more time, then by all means, just stick with me and I will talk you through. I'm going to put 8 here and I'm going to put 6 here, call it centimeters. I'll happily go through this, okay? So we are looking for x. So hit pause, have a go, you know, it doesn't matter what happens, just having a try is a good thing, isn't it? And then hit play when you're ready. Okay, so whilst I'm building my confidence in this topic, I'm not going to take any shortcuts. I'm going to say, right, there's my pointing arrows. That means that I have those edges with those numbers. And then I'm going to write a squared plus b squared equals c squared. I'm going to write that formula. I'm not going to not do that. So that I can then say, okay, I'm going to say a is the 8. And I'm going to say b is the 6. But I could have done it the other way round. So if you did this, but you wrote 6 squared plus 8 squared, makes no difference. You are not wrong, okay? And then that equals my x, which is also squared. Now I can do this piece of maths, 64 plus 36, that equals x squared. Tidy it all up and I've got 100 equaling x squared. And then I want to get rid of that power 2, it lands as a root. Square root of 100 is 10, so x is equal to 10. So hopefully if you pressed pause, that went well. If you didn't, then you must this time, okay? Be brave and literally go for it. The worst that can happen is it goes wrong. And to be honest with you, it's hardly the end of the world, is it? At least you will have tried. So you're going to need your calculators. Hit pause, go through those steps, and then hit play when you're ready. Okay, so we are pointing to those edges. There we go. I'm going to write my a squared plus b squared equals c squared. And I can see I've got a number and I've got a letter. Well, I can't change that fact. That's what I've got. Now, my habit is to put the letter in first. I don't have to. It's just what I do. Okay. B is turning into 5.3 squared, and C as a number this time, 6.8 squared. But there is still just maths there that I can actually do. So I'm going to do my powers first. So I've got x squared plus 28.09 equals 46.24. Now, if I want to know what x equals, I've got to get it on its own. We've got two things now. We've got this add 28.09 and this power 2 to move. Last thing I say, first thing I hop, or you can be thinking Bidmas backwards. That's going to land as a take. We've got 28.09. So I've got x squared left, that's gone, equaling this piece of maths. which is 18.15, power 2, roots it, and I've got x equals 4.260, and on it goes. I'd read my question and I'd round to whatever they told me to round to. So this one was a little different because the x was on that left-hand side. It meant there was an extra step to just get that x on its own, but that's all it meant. It didn't make it like 10 times harder. It was just one little detail. So again, it's really important to just see this as literally depositing information from the diagram into the formula and getting x on its own. That's all it is, okay? Right, let's do another one. We are going to put 6.7 and 10 next there. There's the right angle. Off you go, find the missing edge. Press play when you're ready. Okay, so I have these edges, which has an x and a number. So I've got a squared plus b squared equals c squared. I've got a letter, so that's going in first. Like I say, you don't have to. It's just my habit. I like it in that order. I've got 6.7 for b, and my c is 10. So that'll be 10 squared. Now I can do some of the maths that's going on there. So I've got x squared plus 44.89 equaling 100. Hop to the other side, it's going to land as minus. And you've got x equals 55.11, and that's x squared, sorry, should have put that on straight away. To get x on its own, we will square root, and we've got x equaling 7.423, and on it goes. Hopefully it's going well. We'll do one more, and then we'll have a little look at how Pythag could be used in an application way rather than just in a kind of skills way. So this is, if you were given this type of question, and they certainly come up in the exam, if you were given this type of question where you just have a basic triangle given to you, I'll put 7.3 on there. If you were given just that basic triangle and asked to work out that missing edge, and like I say, we do get questions like this. They're really just testing, can you recognize it's Pythagoras and can you remember the formula and use it? They're not really doing anything more than that, which is what's keeping it at grade 4. But when you start to problem solve with Pythag, takes it to grade 5. And we're going to see that because we don't want the Pythagoras to be in 2 different courses. So we're going to let that extend over as we're doing it, okay? So do this last one. Hit play when you're ready. Okay, so we've got this edge and this edge. They both have the numbers, so that's good. A squared plus b squared equals c squared. 5.2 squared plus 7.3 squared is equal to x squared. So I've taken the information, I've got it in the right place. Now it's just a case of getting x on its own. Okay, so I can put 5.2 squared plus 7.3 squared into the calculator in one go. I don't even have to do it separately if I don't want to. That would give me 80.33 equaling x squared. And then obviously I'm going to square root that, and I've got x equals 8.96, and on it goes. I have got enough of my working out down on the page to get full marks. All right, so there are your basics. That's your grade 4 skill. We can develop by having it in a question where it's not obvious. So this question is work out the surface area of the prism. Well, this is something that we know and that we're good at, okay? And if we were to crack on with this, because we wouldn't be thinking, oh, is Pythagoras hidden in here somewhere? We would just be thinking, oh, surface area of the prism. Okay, I'll find the front, double it for the back, and then I'll work on my edges. So we do that, okay? So we've got the front. being 6 base times height, 6 times 8.2 divided by 2, which is 24.6. And then the back is 24.6. So it started really well. I'm going to do the base, which is 8.2 times 5, which is 41. And then the side, which is 6 times 5, which is 30. And then I've got the slope, and that's when I then hit my problem. I need to multiply this edge by 5, and I don't have that edge. And there was nothing in the question until I got to this stage that made me realize that I had an extra problem within the question. So yes, the question's surface area of a prism, but I cannot answer that unless I know how to find that missing edge. And that missing edge is on a right-angled triangle, which is telling me that Pythag could be applied and it will find me that missing bit. And that is the expectation. So this is the question. So I'll squeeze it in underneath. So we're going to do our a squared plus b squared equals c squared. I can see, I know I've highlighted the wrong thing because obviously I was trying to show you something else, but I can see that the right angle is pointing at those two edges, which means I've got 6 squared plus 8.2 squared equaling c squared. I haven't got a letter on there, so I'll just keep the letter that's in the formula. Okay, throw that all the way into my calculator and it's going to give me 103.24 equaling the c squared, and then square root that and you get 10.1607, and on that goes. Now what you want to do here is leave that, literally leave that on your calculator screen. You don't want to round it, you don't want to mess with it because it's an exact value for that edge, and I want to use that exact value when I'm working out the front face. So what I would do now is I would say, right, I've got 10.1607 and on it goes. I'm going to times that by 5. So in the calculator, because that's already on the screen, all I need to do now is just press times 5 and equals, and it will get me that answer, which comes out at 50.8035, and on it goes from there. And then I can add. So I'm going to add the front, the back, and the 3 faces that go around it. And that came out as 171.0035. So 171 to the nearest whole number, or 0.0 for 1 decimal place. Okay. Centimeters squared. So that's your total surface area. So Pythag can be embedded. If I've got a missing edge, I can use Pythag as long as I have a right angle available. Okay. So here is another place. I'm just going to get rid of this. Okay. So we've been doing a lot of work with our vectors, haven't we? We know how to draw them and work with them and calculate with them. But when we were doing vectors originally, I told you that a vector has direction and magnitude. Okay, so this column vector draws to this vector line. I've got the direction on, and the magnitude is the length of this line. And I'm now being asked to work out this edge, okay? But it really is nothing more than Pythagoras. You just can't see, you can't even see a triangle unless you put on the movement of the column vector. So the column vector said I had to go forward 8. So I went forward 8 and then down 3. When I put those markings on, there it is, absolutely 100% triangle with a length of 8 and a length of 3. The right angle is here. So those numbers are at the beginning of my formula. So I've got a squared plus b squared equals c squared. I'm going to say that the 8 is a and the b is 3. And that is going to be the magnitude of my vector. So 8 squared plus 3 squared, just stick it straight in that calculator. It's going to give you 73. And then square root. And the square root is 8.544. On and it goes. So we'll do 8.5 to 1 decimal place. All right. You would put units in if you had units. I've automatically done it without thinking. There aren't units, so really we would leave that blank. The magnitude is 8.5. If it was centimeters, it would be centimeters in the answer. If it was meters, it would be meters in the answer, and so on. So Pythag, who would have thought Pythag would be part of our vector topic? So Pythag just sneaks in anywhere it can. Anywhere there's a right angle triangle, it can be there. All right. So what you're going to do is practice. So again, you've got this available to you as a full worksheet. It looks like that. I'm obviously going to do my usual zoom in for those of you that want to just work from the screen. It's absolutely fine. And I'll do the same slow scroll through the answers. And then I will see you next session. So really, really well done. I'll get rid of me. There we go. Okay, so question 1 are your grade 4 questions. If you found the worksheet got pretty tricky pretty quickly, it's because it did jump through to those grade 5 areas. And they are hard and they will take practice, okay? So for question 2, we needed to insert a line and create the right angle. We could do that because it was isosceles, so it would create that symmetry and give that base of 6. Okay, so that's what that question looks like. Question 3, I've said it before and I will say it all the time. Really, really important to draw a model, draw a picture, get a feel for what they're talking about so that you can then start to see where everything is supposed to go and you can then transport it from the diagram in. It's a really easy way for the examiner to make it 10 times harder. Instead of giving them a diagram, we'll put something in a sentence instead. And then this last one is extra hard. Now, I would say on this one, it's very unusual to see something this hard on a foundation paper. It is part of our curriculum, so it is part of what we learn at that level. However, very, very rare. So if you struggled with that a little bit, don't worry about it. But equally, go through the steps in what I did to get that. I had to work twice. I had to find one edge and then I had to use that to finish it off. So you can see that Pythag had to be repeated. Have a good look at how it's done and don't just read. If you're really confused, maybe write it through and make the connections within the diagrams as well. All right. I will see you next session. Really, really well done, guys.